I'm gonna hand out this paper also. This has our different particles, and any of these could show up on the test. So I would probably write them on my note card, unless there's one like the electron that you're like, oh, I know an electron. I don't do that one.
I've said that so many times, like in the past 20 minutes.
This is also on Canvas. If you lose it, there's a link on Canvas.
Gamma rays will turn the hole into a hole.
Oh, I don't know.
I think so.
Yes,
all right.
they are
Okay, so this is what you need to know. This is from chapter 2.
so sorry.
So when we have an element,
That's a compliment to me.
do you remember what this number is called?
That's a letter.
Subscript.
So.
It's that one's actually a superscript.
Oh my gosh, I'm like.
But we have, let me see if I can remember it. I thought I remembered, now I can't remember. So this one is the, let's see if this board will write too. This is the mass number. Does that sound familiar, the mass number? Okay, and then what do we add to get the mass number, the top number? These big ones.
Wait, what's the what?
So this number at the top. So that's the mass number, that's our superscript number. I think I pointed to the wrong one and that's the wrong one, sorry.
I don't know.
Remember? So this is gonna be our protons
Oh,
plus
neutrons.
neutrons, good.
I remember.
You remember, good. Okay, and then this is the element symbol. Okay, and then what was this one?
Subscript.
Subscript, okay. That is a subscript. What does the subscript represent here? Remember? This one is this is called the atomic number. And this one, so the identity of the element is based on what type of particle? Do you remember? Change the what? Change the element.
Change the what? Oh, the
Electrons.
No.
electrons.
Protons.
Okay.
Good.
We stop.
Oh, we just have to remember.
Take away and add a proton.
Change the protons, change the element. We can change the number of electrons and still have the same element. It'll just have a charge. So these are the numbers that you have to remember. And we've done this once. So now that we have remembered what they are, it shouldn't be too bad. But Alex is going to ask you, what's the mass number? What's the atomic number? What's the element symbol? So remember the element symbol is connected with the number of protons. The mass number, we just need to figure out how many neutrons are there. Okay. All right, and I think, so for this isotope, how many protons? 92. How many neutrons?
Oh, 238. Oh, wait, no.
Thanks for everybody. 146.
Okay, and how did you get that?
I subtracted.
Okay, good.
2 from the big number.
This will be, so 100 and, what do you say? 40?
146.
Oh, that's a 40.
46. Yeah.
My pen tool turned off.
I'm trying.
And that is number of neutrons. Okay, very good. And then if I wanted to, I could look up on my periodic table if I didn't have a symbol. 92 is somewhere on the pink row at the bottom. 92 is uranium, so I can find the symbol. Okay. All right. So the list I just gave you is, oh no, that's not, just kidding. A radioactive isotope is just something that is unstable. So like uranium can be unstable. A lot of the ones past the actinides are unstable, and they just spontaneously break apart, and decompose. So that's a radioactive isotope. You can also have a lot of the higher in the table, they can also be radioactive. Let's see, I think this
Radiation's bad.
radiation is bad.
Those things that should be grown.
I guess you could argue should the Hulk have been grown.
I wish I was a Hulk.
Then you could just live forever.
No, because I could be like King Kong, cause mine
No.
was destruction.
You don't want to do that.
I can't remember what I linked here. So maybe. Oh. Oops.
You just say it.
Right.
Alright, let's just do periodic table. Okay, so when you're done with this, I'm going to show you on the periodic table, the ptable.com. I don't know if we looked at that, but. So you do not have to remember this. This is just like a side fact. Of the known isotopes of all elements, 264 are stable and 300 are naturally occurring but unstable. So you do not have to know that. I think that's just interesting. All right, so let's go to this ptable.com, and then along the top, usually we look at properties, but you can also look at the electrons, and then we can look at the isotopes. So if you click on one of these elements and you're like, carbon, and then you click on carbon and you drag your mouse, you can see which elements there are, and you can see which ones are stable and which ones are unstable. So the ones that have a blue box around them are going to undergo beta decay. So they're going to emit a beta particle, like on your list. Let's find another one. These ones are stable, so carbon 12 and carbon 13 are stable. Carbon 14 is unstable.
Probably carbons are 22.
This list is 22, yes. Yeah, so like manganese over here. There's a whole bunch, and it tells you how they decay. This one is not known. But, so that's kind of interesting. So if you ever need to know the isotopes, you can click on there. You can also click on like the information, and it'll take you to Wikipedia. Okay, so that is an isotope, something that will spontaneously decay. All right, and then this is just basically your list that I gave you, but the notes that I had before didn't have neutron. Neutron does occasionally come up in the homework, so you should also know neutron. What else?
Wow.
Proton can come out of something that's decaying, and electron also. Okay, so you just need to know the mass and the charge of these. You also need to know the symbol, because Alex is going to have you type it. Okay, so let's just go through a few of these. So an alpha particle contains 2 protons and 2 neutrons, and so that's why this 4 is at the top, because this is protons plus neutrons. So we got 4 and 2. And we can either say, oh, it's an alpha particle, we can use the alpha symbol, or it's the same as a helium nucleus. How do you know it's a helium nucleus besides that it says He? What identifies 2? Good, the 2. The 2 is telling me it has 2 protons, so it must be helium. So this one is when you have like something that's unstable, and then a helium nucleus just pops out of that nucleus. And you have this in your notes. So this is like the first row in your table. Okay, we're just gonna talk through a few of them so that we are on the same page. Beta particle is just a high energy electron. So usually we're going to use electron, or we're going to use beta particle when it's in the nuclear decay. And so this one's kind of weird. We get a beta particle when we have a neutron that splits into a proton and a neutron. The proton stays in the nucleus and the electron pops out. And so what's happening is we're increasing in proton number. So when the electron comes out, we say that it has a negative number of protons. So that's kind of weird. And when you, we'll do a practice problem, but when you write this in your nuclear equation, you do have to show these numbers, and that will help you balance the math. Okay, the next one is a positron. So this is when we have a proton in the nucleus and it changes to a neutron, and then the positron is emitted. So a positron is just like an electron, but it's positively charged. It's the same size, but it has opposite charging. A tiny, tiny proton, yes. So I probably wouldn't call it a proton because it's yes. In the Alex, this is from Alex. In the Alex notes, it's called a anti-electron.
Because isn't there like a theory about like antimatter and stuff?
Yes,
Is this like part of that?
probably. I don't know much about that.
I was
yes.
to video about it.
Okay, so you probably know.
Wow.
You probably know the most. You'll have to tell us at the end of the year. You can do a lecture on
Great.
antimatter. Okay. You'll have to decide what we're doing because if we're a senior, then we're going to be gone. Like after the final, it'll be done. But the rest of us will be here for like another week. So
Yeah.
So you can teach us about antimatter. We can do some labs. Okay. Gamma rays are high energy radiation, so they don't have any mass. They have no charge. We use the gamma symbol. Usually, I like to use zeros, so this has nothing. But I like to put 0. It has a 0 number of neutrons and protons. It has 0 number of neutrons. It has no mass. It's just energy. The other things have mass, but they're so small that we don't usually count it as mass. But an electron has mass, a proton has mass, a positron has mass. They're just really small. But gamma ray has no mass. It's just energy. So this shows up on our electromagnetic spectrum where we have X-rays, gamma rays, UV, visible, ultraviolet, that's UV, infrared. Okay, and then this one. This is the one that I missed last year. So you can also have a neutron emission. So this is a neutron. If a neutron comes out or adds to your nucleus, then this is the symbol we use. So we have 0 protons and we have 1 neutron. Okay. We talked about proton. This would be the symbol. This is the same as a hydrogen because there's 1 proton. Okay, so when we add these together, or when we are writing a nuclear reaction, we have our original nucleus, and then we can also add a particle if we wanted to. But what's going to happen in a spontaneous nuclear reaction is we have something, and then it splits into 2 pieces. So we have a new nucleus, and then something popped off of our new nucleus, and that changed the mass of the nucleus. So what we need to watch for is the sum of the mass numbers on this side have to add up to the sum of the mass numbers on that side. The sum of the atomic numbers have to add up on the right side and the left side. And this is pretty straightforward. People get confused with negative numbers. And part of the problem in Alex is that you have to figure out the particle that's missing. So that sometimes is a little bit tricky too. So I would always, when I do these, especially since our test is going to be like 5 questions, you need to double check. This is the question that happens twice on the test. So add up the math, make sure it makes sense, add it up again, maybe triple check it since we have so much time. But this one's not too tricky, but we just need to make sure that we're being really careful on these problems. So this is like 6th grade algebra. So not too bad. You just have to really make sure that you're being careful. Make sure you bring your brain on the test. And you'll be fine. Okay, I got that for now. Okay, so this is a picture of what's happening. So this one is uranium-238 isotope that is unstable, and it undergoes alpha decay. So we start with this thing, and then out pops a helium nucleus, this He4N2. What else is that called? What's the first particle on your list? Alpha particle. Good. So we get this alpha particle. Oh, I guess it's also called alpha emission. And then we have to figure out the new nucleus. So on this side, our mass number is 238. That's probably really small. And then over here, we have to have 4 plus 234. The mass numbers have to add up to 238. Okay. And then our atomic number, we started with 92 protons. Well, we better end up with 92 protons on the right side. So we have 2 from this alpha particle, and we have 90 from this thorium nucleus. If we didn't know that it was thorium, how would we figure out that it's thorium? 90. Good. The 90, we'd find 90 on our periodic table, and that would tell us that it's thorium. Okay. All right, so go ahead and try this one. Write a balanced nuclear equation showing how americium-241 decays to form an alpha particle. So see if you can do this. I'm gonna give you like 2 minutes, and then we'll go over it. Maybe during work time.
Nice? Yeah, we need to use them more. No, I'm saying for rifles.
Oh, right now, it's 99. Right here. See,
Any direction, so in the direction of warfare. Okay. I need to be here, I need to be here. There. We can be here. Mia do that. Okay. Trying to duplicate. Trying to duplicate. Okay. There. Okay, no.
Okay, how are we doing? Ready? Kind of? Okay. Okay, so we have americium. So what's the symbol for that? Okay. AM. And then where do we put the 241?
on the other side.
On the top. Good. That's the mass number. Okay, what's this? What's the number here? Oops, that's the number of protons. Good. Oops. Oh. $95. Thanks. Okay, and then this decays. So it's going to break apart into an alpha particle. So what should we put for the alpha particle? Good, helium. I think Alex will take a lot of variations. Helium is perfect. And then what labels do we put on helium? What's the mass number? Good, and then what's the atomic number? Good, okay. So what's the other thing that we get out here? Okay, NP. And then what labels go on NP, Cameron?
237.
Okay. Okay. All right. Do you guys see that? Okay. So 2 plus 93 gets us back to 95. 4 plus 237 gets us back to 241. And then 93, from 93, we can figure out 93 is NP.
Okay, so if you figure out, I'm still so confused on this.
Let's try another one. Okay, try this one. So,
Okay.
what do we have to put here to balance this?
That makes more sense. So you have to have, 1 down at the bottom.
And it might be, it's gonna be one of these
Zero
parts.
on the top.
A what? A what on the?
It would be a positron, I think.
Okay, and what symbol goes with positron?
Plus. Yeah, B plus. Thank you.
Okay, positron. So yeah, we could do B plus, or we could do, I don't know if Alex has that, we could use, oops. We can use an electron symbol to 0, 1.
0, 1 E is what you would put down here.
Oh, that was it. Oh. There we go. Pen back on. Turn on pen. Okay, so then 1 plus 5 gives us 6. 0 plus 11 gives us 11. So that's another way they can ask this question. Okay, questions on this? Okay, we have 25, we get out in the same time, right? Okay, we have 25 minutes left. So either work on your ALEKS topics, this is at least 2 of the ALEKS topics, or work on the lab 12. We just covered 2 of the 4. Okay.